Welcome to Chapter 7, Using and Configuring Storage Devices. In today's lecture, we will explain common disk storage technologies and backupping data using operating system tools. We'll explain network storage technologies currently available on the market, as well as removable disk storage. And we'll describe available tape drive technologies. And last but not least, explain storage management tools in different operating systems. Today, most computers come with one or more DVD, CD-ROM drives, and at least one fixed hard drive. Removable hard drives and flash drives can be connected also through USB ports and other communication channels. Just to reference, if we say disk with a capital D, we will be referring to a hard drive, and when we say disk with a small d, we will be referring to optical mediums such as CDs or DVD-ROMs. We also need to talk about some storage unit equivalents. Table 7.1 outlines some of these measurements. A kilobyte, for example, is roughly 1,000 bytes. A megabyte is roughly 1,000,000 bytes. A gigabyte is roughly 1 billion bytes. And last but not least, when we talk about terabytes, we are talking about 1 trillion bytes worth of data. In some older PCs, a popular hard drive interface that was used was the Integrated Drive Electronics, or IDE interface. We still see some IDE interfaces in computers today, but for the most part, IDE and eIDE have been replaced with SATA and eSATA drives. Enhanced IDE or eIDE supports higher transfer speeds than its original IDE interface, and it connects up to 4 devices as opposed to 2. Both of these, as I said before, are generally found in older PCs. By the way, when we talk about IDE and eIDE, we are referring to a standard. In this instance, the American National Standards Institute, or ANSI, refers to the IDE standard as the Advanced Technology Attachment, or ATA. The newer high-speed serial version of the ATA interface is called Serial ATA, commonly known as SATA. External SATA, or eSATA, interfaces enable connectivity for an external SATA drive. Through eSATA, you can connect external SATA drives simply by plugging into a port or slot interface. Some of those interface options include the PCM, CIA, and express cards that would go into the PC. There's also an emerging technology out there called LightPeak. It's projected to be a contender for the USB peripheral device market, and it uses an optical connection. Also, small computer system interfaces, or SCSI drives, exist. They're relatively fast and can support up to 8 or even 16 devices. Disks and other SCSI devices are connected together by a cable in what we call a daisy chain fashion. Each end of the SCSI cable, of course, must be electronically terminated to prevent echoes or ghost signals on the cable that would interfere with the transfer of data. A terminator is an electronic resistor that absorbs the signal. It can be built into a device, such as a disk drive, or it can be a separate little utility that simply plugs into the back of the drive. Advances in SCSI have resulted in several enhancements over the years. Ultra SCSI, Ultra Wide SCSI, Ultra 2 SCSI, Ultra 2 Wide SCSI, Ultra 3 SCSI, also known as Ultra 160, Ultra 320 SCSI, and even Ultra 640 SCSI protocols exist. The Ultra 640 protocol transfers data at a rate of 640 megabits per second. It has a 16-bit bus and handles 16 devices. and is used typically for servers and network storage. Serial Attached SCSI, or SAS, is a relatively new technology that supports up to 16,256 separate devices, and it has initial speeds in the 3 to 6 gigabits per second range, and is very compatible with the SATA interface. Here's an example of a SCSI configuration. This particular card allows for two different SCSI cables, one connecting the hard drives and the other connecting external drives. Note the terminator installed at the end of the scanner. One of the first things you should check on a SCSI configuration when there are issues is whether or not the terminator is properly installed. The number of platters, head, tracks, and sectors per track will vary from one hard drive to another. This information is often stored in an area of non-volatile memory in the computer. Additionally, many operating systems keep a table somewhere on the disk that describes the disk in great detail. This includes the master boot record, or MBR, and we discussed the master boot record at length in Chapter 4. The master boot record is located typically in the first disk track and sector and has information about partitions and how to locate them. And the partition table has information about each partition on a disk, including the type, size, and location, as well as which partition to access first to start the operating system. A newer way to partition disks is by using something called the Globally Unique Identifier, or GUID, partition table. We call this the GPT. Newer operating systems today use the GPT over MBR. These would include Vista, Windows 7, and Server 2008, among others. Using a GPT will allow an operating system to handle extremely large disks. Some disks up to 18 exabytes in size. In Windows, the Windows System Information Utility is one way you can view this hard drive configuration information on your computer. Hard disk failures can and do happen, so backing up your computer is an essential practice, whether you're a user or an administrator for a large corporate environment. Most operating systems today offer some sort of backup utility to make backing up data easier. Examples of those utilities are listed in this table here. Table 7.2. For instance, Windows XP used the Backup and Restore Wizard. Windows Server 2003 and 2003 Release 2 also used the Backup Restore Wizard. Both of these could be accessed through the control panel. When Windows Vista came out, Backup and Restore Wizard was replaced with the Backup and Restore Center. It too is started from the control panel. Windows 7 uses something called the Backup and Restore Utility, which is very similar and is also started in the control panel. Server 2008 and Server 2008 Release 2 also use the Windows Server Backup Utility. However, it must be installed as a feature via the Server Manager and then started from the Disk Management Console. Linux and Unix have ways of backing up utilities too, most of which from the command line. Commands such as dump, tar, cpo, and xfsdump allow you to back up your data. And Mac OS X Leopard and Snow Leopard use the Time Machine utility in order to back up your data. Let's take a moment to describe basic and dynamic disks. This is kind of a review from Chapter 4 as we discussed this in detail, but let's go over it one more time. Basic disks are physical hard drives that contain primary and extended partitions, or logical drives that we call volumes, while a dynamic disk are volumes that have the capability of spanning multiple disks. Dynamic disks support fault tolerance. It involves implementing software or hardware to protect against hardware failures, power interruptions, and data loss. And dynamic disks are supported by all editions of Windows Server 2003 R2 on up through 2008. And of course, they are supported by some later versions of Windows Desktop's versions, including Windows 7. Basic disks can be converted to dynamic disks by using the Disk Management tool in Windows. Another hard drive interface on the market is something called the Solid State Drive, or SSD. It's a storage technology that uses semiconductors for storage instead of platters. It's similar technologies used for flash drives, but of course SSDs are larger than flash drives and hold more data. Advantages of SSDs over traditional hard drives include no moving parts to break, no sensitive magnetic disks to fail. They tend to be faster when it comes to accessing data, and they tend to be more reliable because there are no fragile drive platters to break. Last but not least, because there's no motor, they tend to have lower power requirements. The big disadvantage to SSD is they're more expensive than traditional hard drive storage, and up until now, it's been harder to find some of the larger sizes in SSDs due to the constraints in technology, though that is improving. RAID arrays, or redundant array of inexpensive or independent disks, serve four purposes. They improve reliability. They increase storage capacity. They increase speed. And they also provide fault tolerance. Various RAID designs typically are designated as level 0 through level 5. We talked about this as well in Chapter 4. A RAID can be costly and is primarily used on servers, particularly in a corporate network. However, with Windows 7, some RAID options are available to be used on dynamic disks. RAID is typically implemented as a combination of hardware and software. The hardware provides hard disks connected to a controller. Software provides an interface to the operating system to provide access to special RAID features that are offered. Modern RAID systems offer configuration at the hardware level. It does not need an operating system to configure RAID. We will be discussing RAID in a little bit more detail in Chapter 11. Let's talk about CDs, DVDs, and Blu-rays for a moment. CDs, or compact discs technologies, require a polycarbonate plastic disc that has a reflective optical surface that's read by a laser. A CD-ROM is a compact disc that's read-only memory as used in a technology where information is literally pressed onto the disk at one time. Of course, we can read this disk many times after it has been pressed. CDRs, or compact disc recordables, allow the user to record information onto the disk in one pass, commonly referred to as burning a disk. They're very similar to CD-ROMs in the sense that they cannot be rewritten. CD-RWs, on the other hand, are rewritable. I can write to that disk many times. Now, CDs store data in a big spiral instead of tracks and sectors like hard disks. Very similar to old vinyl records for those of you who remember them. When a disk is read, a laser light is emitted by the CD-ROM drive head and it's reflected off the disk surface onto an optical pickup lens. The surface is covered with indentations, or pits as some people call them. Depending on the size of the pits, ones or zeros are returned. The surface of a CD reflects light during a data read operation. Now, CDs are very sensitive to scratches and other kinds of damages that can hinder that optical readout. Data on the CD, of course, can employ any or all of the following error recovery methods. Parity. Parity is a simple error detection method that typically counts the number of non-zero bits in a string of data. It then sets a parity bit to reflect whether those bits total an even or an odd number. It also has error correction codes, or ECCs, which can replace errors by adding duplicate data or parity data so missing data can be recovered. The process of error concealment uses surrounding data to help calculate approximate data to fill in for that missing data. A cyclic redundancy check code, or CRCC, uses an algebraic, polynomial, and error key to detect and overcome errors. Last but not least, the Reed-Solomon, or RS codes, uses a complex polynomial technique for addressing data errors. A typical CD holds about 730 megabytes of user data. Now, you also have to add space for error detection, so the true capacity for a typical CD is about 847 megabytes. CDs are rated in terms of recording minutes as well as megabytes, since oftentimes they are used for music or audio as well as for data. The rotational speeds of a typical CD-ROM drive range from the normal speed of 200 to 500 revolutions per minute. Now, there are CD-ROM drives that can go as high as 72 times that speed. And you will know those drives because they are written similarly, like 72X, or 4X, or 12X, which would indicate how many times the average speed that drive is susceptible for writing. Digital video discs, or DVDs, work a lot like a CD, but storage capacity and data transfer rates of DVDs are much higher than that for a CD. DVDs can store information on two sides with up to 2 layers per side. And unlike CDs, DVDs have a second layer that is read by using the light that hits the disc at a slightly different angle. Now, a single-layer, single-sided DVD is capable of holding 4.7 gigabytes of data, while a double-layer, single-sided DVD holds 8.54 gigabytes. Double-layer, double-sided DVDs hold a whopping 17.08 gigabytes of data. In addition to CD and DVD devices on the market, there are recordable and rewritable DVDs. The DVD-R and the DVD+R devices are slightly different in how they work. Table 7-3 provides information on each of the DVD devices. DVD-ROMs are pressed on once and read many times. A DVD-ROM drive can typically read all types of DVDs and CDs. A DVD-R uses similar technology to a CD-R in that the medium can be burned once and read many times. The DVD-R can be read to a DVD-ROM drive, but it requires a DVD-R capable drive to burn the DVD. A DVD+R uses a slightly newer technology than the -R and offers a different method of tracking than the DVD-R. There's also DVD-RAM, which is a recordable and erasable medium. The DVD-RAM drive can read DVD-RAM, DVD-R, DVD-ROM, and CD-R discs. The DVD-RW and the DVD-ER are erasable and recordable drives. They can be read to most DVD-ROMs drives, but requires a DVD-RW or ER compatible drive in order to erase or record to those discs. And last but not least, a DVD+RW, which is similar to the -RW and of course is also readable in a typical DVD-ROM and a DVD-RW compatible drive. Writing, of course, to a DVD plus RW disc requires a compatible drive. DVD, CD-ROM drives, and the like are usually connected to a computer using a hard disk interface. Most PCs use the SATA, EIDE, or SCSI interface. They require different drivers than hard disk drives. But most PCs have the drivers built into the BIOS system, and they can boot from these drives. Most PCs can also boot an OS directly from a CD or a DVD for initial installation. Blu-ray discs are different from DVDs and CD-ROMs because data is literally recorded on top of the polycarbonate layer. It enables the information on the disc to be read more accurately without all the problem of disc tilt. Data transfer speeds for Blu-ray drives can reach 36 megabits per second. This, compared to 10 megabits per second for DVDs, make it the true leader in the industry as far as data transfer rates for disk drives. Current storage capacity of a disk is a maximum of 50 gigabytes, and they are typically connected to the computers with a SATA interface. Now, to play a Blu-ray video, on the other hand, you must have a video display compatible with something called High Bandwidth Definition Content Protection, or HDCP. Now let's talk a little bit about network storage and cloud storage. You see, organizations today are having to deal with massive amounts of data, and the amount of data is always increasing. Some of the reason why we have so much data is because nowadays we are required for legislative or regulations to create backups, be prepared for disaster recovery, and of course having that availability of data are reasons why storage on area networks and cloud storage are growing in popularity. Some of those include storage area networks, or SANs, which is a grouping of storage devices that form a small private network. Data transfer in a SAN is between servers and the storage systems, and typically takes place on something called a fiber channel. The typical speed for most fiber channels is about 8 gigabits per second, and there are 16 and 40 gigabit per second fiber channels currently under development. Here is an example of a network storage called a SAN. On a SAN, you will notice that servers are directly connected to the local area network, and the SAN itself is connected to these servers via a fiber channel switch. InfiniBand is designed for ultra-fast connectivity in data centers, such as linking servers for clustering to act as one powerful server. It has emerged as a new alternative for fiber channel. Another storage medium apart from SANs are NASs, or network attached storage devices. They connect directly to the local area network. Now, one of the advantages of NASs is that they work with multiple operating systems, and they use TCP/IP as the standard network communications protocol. They are different than a SAN. Servers communicate with the storage over the main network, other than using the fiber channel separately. NASs can use Internet Small Computer Interfaces, or iSCSI, for communications as well, but they offer TCP/IP-based communication, which enables connectivity with SCSI-based storage arrays. Typically, NASs are faster for data access than fiber channel because data transmission speeds are linked to the actual speed of the network, and because it uses TCP/IP, you can use NASs on LANs, WANs, or over the internet. There is a disadvantage to using a NAS. it does create extra network traffic, and this can lead to network congestion depending on how it's used. Here is an example of a NAS. Notice the differences between the NAS and the SAN. In this instance, the servers were still connected to the local area network, but so is the NAS through a switch. In addition to SANs and NASs, there's something that has been creeping up on the market over the last few years, which has really gained popularity, and that's cloud storage. Cloud storage is available through the internet or through web-based applications. Data can be transferred to cloud storage over the internet or over a network using the user's computer, or the user can manipulate the data on a remote computer via the internet. Users' data is available from any location wherever they can connect to the internet. Cloud storage also provides fault tolerance because this data is typically backed up, and it's backed up off-site. Now, some examples of cloud storage that you may not be familiar with are YouTube, which hosts millions of video files, Google Docs, which store document files and spreadsheets, and there are many, many others out there. These are examples of cloud storage. Now, in cloud storage, typically files can be made public, or you can opt to keep them private. You can't talk about data storage in today's world without talking about removable disks. Some early examples of removable disks include floppy disk and zip disks. And floppy disks usually store data at 1.4 megabits, while a zip disk can hold 750 megabytes. Today, users expect removable storage capacities to match hard disk capacities, making floppy disks and zip disks completely obsolete. Some removable hard disks can connect to USB ports and hold over 1 terabyte of data. Another removable hard disk options include SSDs, which will connect to the computer through a USB port. Still, other options for removable disks would include eSATA and LightPeak technologies, which we talked about earlier. Another form of removable data that's very common in today's market are flash drives, also known as thumb drives. They too plug into the USB port and have no internal moving parts. They don't require additional drivers typically and are quickly recognized through plug and play. They're easy to use and they fit in your pocket. This makes them very convenient, but it also makes them a security risk, as they can often be lost. Typical sizes, at least at this point, include 4, 8, 16, 32, and even 64 gigabyte flash drives. Now, flash drives will work in Windows, Unix, Linux, and even the Mac OS operating system. Table 7.4 talks about some of the storage media capacities and the lifespans. For instance, fixed hard disks tend to average about 5 years if it's used 8 hours a day, while solid-state technology also takes about 5 years for it to burn out, or roughly 10,000 writes per memory cell. When we talk about storage mediums like CDs and flash drives, the average lifespan depends. For CDs, 2 to over 30 years, depending on the quality of manufacturing for the CD. A DVD could be stored for 100 or more years, depending on the quality, as such as Blu-ray as well. Now, flash drives, well, that depends on the wear and tear and the type of memory cells, but on average about 10,000 writes for multi-layer cells and about 100,000 writes for single-layer cells. Now, tapes and tape drives were one of the original ways that data was stored on a computer system. 70s TV shows used to show these large data banks with big swirling reels of tape spinning in circular fashion as the star of the show was pulling data off the computer. We don't use tapes and tape drives anymore to store large amounts of data on day-to-day usage. However, tape backup systems are alive and well and are the traditional choice for backing up large amounts of data. Of course, tape backups use magnetic storage and record data in sequential order, not blocks of data like typical hard drives. Now, there is a disadvantage to using a tape. Of course, in order to find a file near the end of the tape, a tape drive must first go through all that data recorded prior to that file. And access to that data in a tape drive is typically slower than a removable hard drive today. Tape drives are generally more popular today for long-term storage. With disk drives growing into terabytes, tape drive technology, of course, is also having to evolve in order to keep up with demand. And tape drives are slowly being phased out in favor of things like cloud storage and other mediums. Some of the tape media capacities are shown here in Table 7-5. Let's talk about some of the various tape drives that are available in today's market. DAT drives, or digital audio tape drives, are still in use. They use a 4mm tape and the digital tape storage DDS format. Now, the original format, DDS1, had a capacity of 2 GB, or 4 GB when it was compressed. And today's current standard is DDS5. It has a storage capacity of 36 GB, or 72 GB respectively when it's compressed. DDS is backward compatible. That means that when I upgrade to DDS5, I can still read my DDS4 tapes, and it's rated typically at an archival life of about 10 years. Still used for audio recordings, of course, this tape is also been replaced for the most part by other tape technologies when it comes to data storage. DLT drives and SDLT drives are seen in corporate environments quite often today. DLT stands for digital linear tape. They use half-inch wide magnetic tapes and record data in tracks, which offers a high-speed search capability, so a file can now be found in a few seconds to a little over a minute. Now, DLT drives are used in many automated tape backup systems in corporate environments, as well as SDLT, or super digital linear tapes. SDLT drives use both magnetic and optical recording methods. Laser technology, of course, is more accurately capable of writing data to the tape, and it will allow for greater density of information. For instance, I can compress an SDL tape up to 2.4 terabytes. Both DLT and SDLT have an archival life of 30 years. AIT drives, or Advanced Intelligent Tape, was first introduced in 1996 and is typically seen on mid-range servers. AIT drives have an erasable memory chip inside the cartridge that stores the information that would normally be written at the beginning of the tape, like a master boot record. And it can fast forward and pinpoint information faster. It started out with a capacity of 35 to 90 gigabytes. SAIT drives, or Super Advanced Intelligent Tape, has a capacity of 500 gigabytes to 1.3 terabytes, whether it's native or compressed, respectively. Both of these drives can sustain up to 30,000 tape passes and typically have an archival shelf life of 30 years. LTO drives, or linear tape open, is most widely accepted in what we call high-end servers. High-end servers require high-speed performance. Now, LTO is a standard that's open to the public, and it is non-proprietary. LTO Ultrium was a format developed so that LTO tapes can be used for existing DLT tape drives to help facilitate faster conversion to LTO Ultrium technology. They offer fast data transfer speeds of up to 240 megabits per second for non-compressed data, and roughly half that when you compress it. You can sustain up to 260 tape passes and have an archival shelf life of 15 to 30 years. LTO drives may not be the drive of choice if you're going to be writing to these cartridges on a routine basis. Let's talk about some of the storage management tools that are available for operating systems. For instance, the Windows storage management tools. Windows Disk Management Tools for hard drives and removable storage is available in the following versions of Windows: Windows XP, Vista, and 7 for your desktop operating systems, and Server 2003 and beyond for your server systems. The Windows Disk Management tool will enable you to create, format, and delete partitions. You can also manage partitions from this tool, as well as manage removable storage, including hard drives, DVD, CD-ROM drives, and even flash drives. I can also convert a basic disk to a dynamic using the Windows Disk Management tool. I can access this tool from the Computer Manager. There are also other utilities in Windows that will allow me manage my disks. This includes the Disk Defragmenter, Check Disk, and Format, all of which we've discussed in Chapter 4. Here is an example of the Windows Disk Management tool in Windows 7. In this instance, you will note that disk 0 is the hard disk with roughly 700 gigabytes of memory. The disk is broken into 3 sections. Part of that section is not used. Unix and Linux also have disk management tools, but most of these tools are accessed through the command line. They require utilities such as fdisk, format, sfdisk, and cfdisk. sfdisk and cfdisk will enable you to verify partitions, list information about the partitions, and even repartition a disk. The command line utility mount is also important. It will allow you to mount a file system so that you can use the disk partition. Many of these will need to be manually mounted in Linux. This includes DVD-ROMs and CD-ROMs or even flash drives. These can be mounted pretty much anywhere in the file system. In Linux, there's also some GUI tools available, for instance in the Genome Desktop. Here's a Genome Disk utility that you can use. In this instance, we have selected the CD drive. Table 7.6 shows you some of the typical commands that are used to manage storage management tools in Unix and Linux. Last but not least, Mac Operating System 10 has a disk utility as well. It allows you to partition, format, and manage hard drives, DVD, CD-ROM drives, removable hard drives, flash drives, and other storage devices. Of course, the options that will be available will depend on the type of storage medium you've selected. When you select a storage medium in the left pane, the utility displays appropriate tabs for the actions you can perform on that particular storage medium. Because Mac OS X is Unix-based, you can also open a terminal window and use the mount command to manage storage media. Here is an example of the Snow Leopard disk utility for Mac OS X. In this instance, we have selected a 251 gigabyte MaxStore hard drive. Let's summarize this chapter. In this chapter, we provided you with an introduction on how operating systems interface with storage devices, and we give you an overview of the storage device technologies. Some popular computer storage technologies include hard disk drives, solid-state drives, RAID arrays, CD, DVD, and Blu-ray technologies that interface to the computer through the operating system and device drivers. Now, one thing that you should get through this lecture is that an important part of learning to manage hard disk storage is performing backups. Accidents can and will happen on your disk storage, and it is important to have a backup handy so that you can restore yourself to a productive point in short order. Network storage devices to store large amounts of data would include things such as SANs, or storage area networks, and network attached storage. Cloud storage also enables you, the user, to access storage through the internet or through a network using web-based interfaces. SANs use fiber channel or InfiniBand technology, while NAS uses iSCSI storage technology or typical internet protocols to transfer data. Modern medium to large capacity removable storage includes USB attached removable hard drives, USB solid state drives, eSATA drives, LightPeak drives, and USB flash drives. Some of the common tape storage options available in today's market include DAT, DLT, SDLT, AIT, SAIT, and LTO drives and tapes. Operating systems, for the most part, will come with some sort of storage management tool, including the Windows Disk Management tool for late versions of Windows, the Disk Utility in GNOME for Linux, and the Mac OS X Disk Utility. That concludes Lesson 7.